For this problem, we have solve the integral of x to the fifth cosine of 4x dx. For this problem, we can use integration by parts, and the formula for that is uv minus the integral of v du. Here we can say that x to the fifth is our u, and cosine of 4x dx is our dv. If we find the derivative of x to the fifth over and over again, it will eventually reach 0, so we know that here we can use the tabular method. So with this we can say that we have our u, our dv, and we can list them here. The derivative of x to the fifth would be 5x to the fourth, then 20x to the third, then 60x to the second, then 120x, then 120, and lastly 0. With these formulas, we can easily find the integrals of dv. The integral of cosine of 4x will be sine of 4x over 4. Then it will be negative cosine of 4x over 16. Then it'll be negative sine of 4x over 64. Then it'll be cosine of 4x over 256. Then it'll be sine of 4x over 1024. And lastly, we have negative cosine of 4x over 4096. From here, we can list our negatives and our positives. We always start with positives. The negative, positive, negative, positive, negative, and positive. Then from here, we can multiply. With the tabular method, we multiply this with this value, this with this value, so on and so forth. Eventually, what we would get is x to the fifth times sine of 4x over 4 minus 5x to the fourth times negative cosine of 4x over 16 plus 20x to the third times negative sine of 4x over 64 minus 60x to the second times cosine of 4x over 256 plus 120x times sine of 4x over 1024 minus 120 times negative cosine of 4x over 4096. Then we add our constant of integration plus c, and that is our answer.